Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. Now take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Taxi Rank by Marty Sears, and here are the rules. Normal Sudoku rules apply, which means fill the entire grid, 9 by 9 grid, with the digits 1 through 9 without repeats in any row, column, or box. The digits along each colored route can be read as a 6-digit route number, starting at the square. Okay, I guess this is a square. It looks like it's a diamond, but basically since it's going diagonally, that's why it's a diamond shaped, because it's trying to go from the square to the next cell. So they're squares if they move orthogonally, but if they move diagonally, they turn into diagonals. So we start at squares and we finish at a spot. These 9 route numbers can be ranked from lowest to highest. A circled yellow taxi on a route indicates that route's rank. A 1 taxi would be on the route with the smallest 6-digit route number. None of the route numbers are the same, so there are no tied ranks. The digits are along a route. So basically, the route number for this pink would start from here, go to here, go to here, go to here, go to here, and it ends there, right? So that's the route number for this line. Same with this one. This would be the route number for this line. So the 9 route numbers can be ranked from lowest to highest, right? So we have a circled yellow taxi. Okay, so this circled yellow taxi indicates the route rank, the route's rank in this order, right? So, for example, if this were, say, the 6th ranked route number, which means it's the 6th highest, or actually, it would be the 4th highest. It'd be the 6th lowest, right? Is it? Yes, it would be the 6th lowest. So it ranks from a 1 taxi is the smallest 6-digit route number, and a 9 taxi is the highest 6-digit route number. So, and there are no ties. So a circled yellow taxi. So if this were, say, a 6, that would mean it's the 6th smallest and the 4th highest route number of the route numbers. And that's what the circled yellow taxis are. And there's 5 of those. Right? 1, 2, 3, 4, and 5. So that route specifically would have to be that rank. We also have box borders divide a blue route into segments whose digits have the same sum. So, for example, these 3 digits would sum up to the same as this digit, which sums up to the same as that digit, which sums to the same as that digit. And we know that because the box borders divide this route line into this is a segment, this is a segment, and this is a segment, and this is a segment. We also know these 3 must sum up to what these 3 are. These 2 must sum up to what these 3, which must sum up to what that 1 is. And that's how this is a region sum line. And this is a typical coloring for a region sum line. Adjacent digits on a green route have a difference of at least 5. So for example, if this were a 3, this would have to be an 8 or a 9 because the only digits that can be between or that can be next to a 3 on a German whisper line are 8 and 9 because they have a difference of 5 at least. And digits on a pink route form a non-repeating consecutive set in some order. So this is a typical Renban line. So as an example, you could have something like, I don't know, 3, 5, 4, 6, 8, 7. And that would work because all of these digits are consecutive to the pack, essentially. There's no spaces in between, essentially, if you go from the lowest to the highest digit in the 6th set. In this, on the digits on the line, right? And remember, it's non-repeating for the pink routes. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so like I said, these 3 digits must be the same because the box borders divides these into segments, and they're only one cell each. These 3 then must add up to what this digit is. So this is 6, 7, 8, and 9, 6, 7, 8, 9, 6, 7, 8, and 9. Interesting. So this is the 6th, 7th, 8th, or 9th largest 6-figure sum. Or 6-figure route. 6-digit route number. It's at least 6th, though. That's interesting. So this is a high. And on a German whisper line, you'll alternate between high digits and low digits, right? Because 6, 7, 8, and 9, well, what can those digits be next to? 6 can be next to 1, 7 can be next to 1 or 2, 8 can be next to 1, 2, or 3, and 9 can be next to 1, 2, 3, or 4. So that means one of these digits is 1 through 4. This is 1 through 4. This has to be 6, 7, 8, or 9, though. Wait, how does that work? That's very interesting. This is saying because it alternates between highs and lows, and the reason why you know 1 through 4 is the same as the opposite of 6 through 9, right? So this is 6 through 9, and this is 1 through 4. But this being either the first, the second, the third, or the fourth smallest route number means this, and it starts with a 6 at least, means this has to be a 6. So this is 6. This has to be 1 or 2. This is 1 or 2. This cannot be 1 or 2. This has to be the 9. So this is the 9th largest, or the 9th smallest, or the largest, essentially, route. So this has to be 6. This must be 6, which makes this a 1. This is 9. This can no longer be 1. This can't be 6 or 9. This has to be 3 and 8 here, which means this can't be 4 because it must be next to an 8 at least. So this is the second or third largest one. This 1 means this can't be a 1. So this is 2. This is 1. So this 9th smallest, or essentially the largest, route number is 621,999. That means, interesting. And the second or third smallest route number is 619. So All of these then must be 6. And this is 1 or 2 here. This is 1 or 2. And this is at least 9. Huh. That's interesting. Well, this cannot be 6, 1. So this has to be smaller. This has to be essentially 1 or 2 here as the smallest of the route numbers. This has to be 6, 7, 8, 9. 1, 2, 3, 4, 6, 7, 8, 9. This is 1, 2, 3, 4. But these can't be 1. Therefore, this can't be 6. It can't be 7 because it can't be 9. Therefore, this is 8, which means it's next to 2 and 3. This can no longer be 8. This can't be 9. It can't be 6, so this must be 7, which makes this a 2, because 2 can only be next to a 7 and an 8 on a Renban line. This must be 3. This is first or second. And it must be 3 and 8. So this is 6, 8, or 9 here. This cannot be 6. So this has to be a third, right? Because this can't be 6. I guess this is 6 specifically. Because this can no longer be 6 here. This is a 6, this is a 6, this is a 6. And this has to be 6, because that's the only thing remaining. This is 6, 1, 9. This must be third. So this is 3, 8, 3. This is first or second. This has to be first or second. So this is smaller than 6. It's 1 through 5. All the 6's must be next to 1 or 2. So this is 1 or 2. 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 So all the 6 route numbers must have a 1 or 2 next to it. So one of these is a 6, and one of these is a 6. This can't be 6 because of this 6. This is 8 or 9. This is 1 or 2. This has to be 1, actually. So this is 1. This has to be 9 because this third route has to be less than this. Therefore, and it cannot be 3, so this is 4, this is 9, and this is 1, 2, 3, or 4 here. Therefore, this can't be 6, 1, because if this is 6, 1, this would have to be 5 at most, and that's less than 6, 1, 9, but we already have all the digits that we have less than. So we have, this is 6, well, we don't know if this is 4th or not. It's at least 4th, 5th, 6th, we don't know. Remaining digits in column 1 are 3, 4, 5, 7, 8, 9, but none of these can be 9. This can't be 7, this can't be 4. So it's 3, 5, 7, or 8. This cannot be 6, 1, because if this is 6, 1, it would have to have a 9 to be in between the 6, 1, 9 and the 6, 2, 1. So this has to be 2, which we already knew that. That's 1. Okay, so this is 6, 2. This is at least greater than this 6, 1 and this 6, 1. So it's at least 5. So this can't be 3. This can't be 9. This has to be 4, 5, and 7 remaining in column 2 in box 1. This must be 1, 3, and 8. This is the 6th largest one. It cannot be 9 here, so this must be 6, 2. This is 6, 2, so one of these is 6, 1. This is 6, 2 also. 6, 2, we don't know what that is. Actually, it has to be 1, right? So all of these are 1 if they're 6, 2. So this can't be 1 here. We have... So one of these is a 1. We don't know which. This can't be 1, so this is 6, 2 with a 1 here. So this can't be 1 or 2. Okay, so this 3, 8 pair eliminates 3, 8 from the rest of the box. This can't be 1. Where's the last 1 in this box? It has to be here. So this is 1. We have... 1 has to be 1. Okay, this has to be 6, 2, 1 also. So this, because any 6, 2 has to end with a 1 in the third digit. This is 2. So this is the second largest one. So it must be 3, 8, 2, 7, 2, and we don't know what the last digit is. Therefore, this has to be 2 or 3 here. The sum of these 3 digits is the same as sum of these 3 digits. The sum of these 2 digits is 8. So this must be 8, and this cannot be 2, 5. It has to be 3, 4, which eliminates 3 and 4 in the rest of the box. So this must be 2. This can't be 3 or 4 because of the 3, 4 pair in the row. The remaining digits here have to be a Renban, and it must contain 1, 2, and 6, so this must be 3, 4, and 5. This can't be 3 because of that 3. This must be an 8 here, which means the rest of the box cannot contain 8. Where is the 3 in column 1? It has to be here. So this is 3. So this is 1. This is 6, 2, 1. This is 6, 2, 1. 6, 2, 1 could be 3, 4, 3, 4, 8. We know it's 8 here. This has to be a Renban, so it's 3, 4, 5 also. But this can't be 5 because it's next to a German whisper line. Therefore, this is 7. We don't know which one this is and which one this is. So we have 3, 8, 2, 7. This is 2. And this could be any sum. We know there's a 6 here, though. And this can't be 7. This is a Renban with 1, 2, 3, 6. So this must be 5th, which makes this 4th. So this is 6, 2, 1. This is 3, 5, and 4. So this 6th one must be greater, so this must be then 4 and 3, because otherwise it'd be 3, 4, 8, which is smaller than the 5th one. This then is 4, 3, and 8. We have we have 2 other Renbans. Okay, so this is the 9th largest. This is the 5th largest. This is the 6th largest. This can't be 4, and this can't be 3. There cannot be anything in between. So this is a 4 and 5. Where is the 3 in row 4? It has to be here. So this is 3. You cannot have a 4, 3, 5 because that would be in between the 5th largest one and the 6th largest one. And that would cause that problem. So this cannot be 4. This has to be 5. This has to be 4. So we have 6, 2, 1, 5, 3, 4. Okay, so the smallest one is this one. The second smallest is 3, 8, 2, 7, 2, 8, or 9. The third smallest is 6, 1, 9, 3, 8, 3. The ninth smallest is 6, 2, 1, 9, 9, 9. The fifth smallest is 6, 2, 1, 3, 5, 4. The seventh, well, we don't know if it's seventh or not. The sixth smallest is 6, 2, 1, 4, 3, 8. We have 5, 3, 4. We have 1, 2, 3, 4, 6, 1, 9. Okay, so this has to be the fourth. So it's 6, 1, 9, 4, 9, and then 3 or 4. We're not sure which. Okay, so that means we probably have to be... Okay, so this we have region sum. This is at least 9. It has to be greater than that. This 4 eliminates this 4, so this is 3. Therefore, this is 6, 1, 9, 4, 9, 3. This can't be 3 because of this 3, so this is 8, which makes this a 3. This has to be 5 and 6 then. 2, 5, and 6 adds up to 13, so this is 1, 3, and 9 here. So this is 9. So we have, this is 1, 3, and 9, and we don't know if it's 5 or 6. This has to be 7. These cannot be 3 here. This 4 eliminates that 4, so this is 5, which makes this a 4. So we have 6, 2, 1, 5, 3, and 4. Right? 6, 2, 1, 5, 3, 4. This is 6, 2, 1, 5, 4, 3. That's the 8th one. This is the 8th largest. This digit is specifically 5. This has to be a 4, 7 pair, but this can't be 4 because of that 4, so this is 7, which makes that a 4. Where is a 2 in row 1? Can't be here, can't be here, can't be here, it must be here. So this is 2. That means we have 8 2s. We know where the last 2 has to be. It has to be here. So this is 2, which makes this a 6, which makes this 5, which makes that a 6. So this is 2, 5, 6 here. Do we have 3s? We have 8 3, so we know where the last 3 has to be. It has to be here. What about 4s? 4s, we know where the 4 is in column 8. Cannot be here, cannot be here because of the 4s in the boxes. Can't be here because they're filled out. So this must be a 4, which means this cannot be 4. Where's the 4 in box 2? Can't be here, can't be either of these because of the 4s in the rows and the columns. Therefore, this is a 4, which means this can't be 4. Where's the 4 in column 2? It has to be here. And that should be 8 4s. What about 5s? 5 in box 6 cannot be here, so this must be a 5. Either of these could be 5, so that's fine. We have a 5 9 pair here. This can't be 9 because of this 9, so this must be 5, which makes that a 9. This 5 eliminates that 5, so this is 7, this is 5. That should be all the 5s. No, we have 8 5s though now, when we know where the last one has to be. It has to be here. So we have all the ones. Actually, we know where the last one is because there's 8 ones. So this is a 1. Twos should be all done, I think. 1, 2, 3, 4, 5. Yep. Threes are all done. Fours are all done. Fives are all done. Sixes are all done. Sevens. 7 cannot be here in box 8, so this must be a 7. This must be a 7 because that's the only place left in the box, which means this can't be 7, so this is 7. 7 cannot be here, so this must be 7. So that's all the 7s then. 8s. Well, the 8 cannot be, has to be here, which makes this a 9, which makes that an 8. Therefore, this is a 9. The 8 has to be here, and then has to be here, which leaves this as a 9. And that's a solution. Yeah, pretty interesting, actually. The restrictions really restricted things a lot. And it flowed very well. Particularly, actually, the break-in. That flowed very well. It limited things quite a bit. Which, actually, thinking about it, this actually could be a very... The limitations on this could have been... Or the possibilities for this not being very limited is quite high. So I guess that's good that it did limit things that much from the beginning. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.